Okay, so in this video, we discuss question 14 tutorial. So the question says that figure 6.2 shows the root mean square voltage across the resistor R, inductor L, and capacitor C. Okay, so basically this one is your VR. VL means that this is the voltage across the inductor, and VC 133 volt. Okay, by using the phasor diagram, find the supply voltage and the phase angle. So the question wants you to find supply voltage and phase angle. So supply voltage is basically Vrms. Okay, and phase angle is basically your phi. And they ask you to use phasor diagram. So first of all, you're gonna draw the phasor diagram. So this is RLC circuit. It consists of three things. So if I draw, it should look something like this. Okay, notice that VL is bigger than VC. So the vector here logically will be bigger, bigger. And the VRMS should be somewhere over here. Okay, so the angle between VRMS and I, the current, which is in this direction, is your phi. Okay, so if you want to find the supply voltage VRMS, you can use the formula. I mean, you can refer to this diagram. So basically VL minus VC square plus VR square, and you should get the Pythagoras over there. So VRMS square root of VR square VL minus VC. So substitute all the values. 141 square plus, forget to put square there, 327 minus 133 square. Take the square root of everything. Should get 239.83. So this would be your VRMS or supply voltage. In the next question, they want to find the same question. They want to find the phase angle. So you can use cos phi if you want to, which is equals to, in this case, you can see that this one is equals to adjacent over hypotenuse. So adjacent is VR, hypotenuse is VRMS. So your phi is across VR is 141, 239.83. So if you use degree, then you get 53.99. Okay. The question B, they ask you to calculate the values of current flows in the circuit if the resistance is 68. Okay, so now it says that the resistance R is 68. Okay, and they ask you to find the current flows. So basically your I, R, and S. Since they give you R, you can use Ohm's law. V is equals to I, R. But remember, current is RMS because we only have one values for current. But V here would be VR. Okay, because you partner it with R. So on the side note, please remember, if you put VRMS, then you should use IRMS Z. If VC, then it will be I RMS XC. And if VL, I RMS XL. So back to this question. So VR is 141. So I RMS is equals to 141 divided by 68. Should get 2.07. Okay, the unit will be in ampere. So that one is for B1. Okay, for B2, inductance and the capacitance of the supply frequency is 50 Hertz. So it says that calculate the inductance and the capacitance if the supply frequency is 50 Hertz. So inductance is basically L and capacitance is C. So given that frequency is 50 Hertz, they want you to find L and C. So you can find L and C from the formula of XC and XL. So XL is basically 2 pi FL and XC is 1 over 2 pi FC. So you have to find XC and XL first, and then you can find the respective capacitance and inductance. So if I go back to these notes here, I can use VC and VL. VL is equals to I RMS XL. I just do it side by side. So let me copy these values down there. Okay, so your XL over here would be 327 over IRMS, which is 2.07. Your XC is voltage for across the capacitance 133, IRMS 2.07. So your XC would be 64.25. Okay, the unit will be in ohm, and this one will be 1.157.97. Okay, now you just want to apply this formula. And then you can find the capacitance. So your C is equals to 1 over 2 pi, frequency is 50 Hertz. Double check, yes. Multiply with the XC, which is 64.25. Okay, on this side you will have L, which is XL divided by 2 pi F. Okay, so your capacitance here you should get 4.95 times 10 negative 5. And the unit will be in farad because this is capacitance. Inductance you should get 0.503. And the unit will be in Henry. And then we still have one more question. So the last part, B3, they want you to find the resonant frequency of the circuit. So resonant frequency is your FR. Okay, so if you guys still remember, I always draw the graph or when it is at resonant frequency, and from the graph you can say about three things. Okay, number one, Z minimum is equals to R. Number two, XL is equals to XC. And number three, cos phi is equals to 1. Okay, from XL equals to XC, actually you can find the resonant frequency. So make sure I write. So I start with XL equals to XC. If I substitute the formula for XL and XC, XL will be 2 pi F L 1 over 2 pi F C. Okay, and because this one is at resonant, so I just label FR as your F. So this one becomes FR and FR. So if I bring FR to left hand side, that will get FR square equals to 1 over 2 pi square L and C. And if I bring the square to the other side, it becomes square root. So your FR is equals to square root of 1, which is 1. Square root of 2 pi square becomes 2 pi. And square root of LC. Okay, since we already have the values for L and C, we can substitute inside here straight away. Your L just now is 0.503. And your capacitance is 4.95 times 10 negative 5. Okay, this one if you calculate you should get actually the formula you can use straight away. You don't have to derive it every single time. Okay, I got here 31.896. So frequency, if I round it off, then it becomes 31.90 hertz.